There have been such a lot of complaints about type annotations from people who don't actually use them that it's lovely to see the tooling maturing in this area. OK, do we have any questions for David?
Maybe not. I can yield to Niels then.
OK, thank you, David. Mats. Demo gods were in your favor. OK, so coming up now, we have Niels, who I've never asked how to say his name, and I've probably said it different every time. Niels or Niles? Niels. Niels, who I did introduce as a recovering data scientist, and now he calls himself a recovered data scientist, and he's going to talk to us about UnionML, an ML machine learning ops framework for building and deploying machine learning microservices.
All right. Hi, everyone, again, if you saw my talk yesterday. Also, forgive me if I get into like a coughing fit. I did test negative for COVID, but I think I caught something in the plane. Note to self, do not drink alcohol in the plane. Compromises your immune system. All right, so so today I'm going to talk to you about MLOps, which is, I guess, a burgeoning field. You know it's burgeoning because DevOps people say, why do we need a new term? And hopefully I'll justify why we need a new term for that in this talk. But at the end of the day, it does ultimately boil down to DevOps. A little background. I'll just kind of skip through this, but basically did a bunch of stuff before, and now I love coding and programming and machine learning, so that's what I do these days. So before I get into the meat of my talk, I'm going to take you through my own personal journey through programming, data science, machine learning. I started roughly a decade ago. I was, at the time, doing a public health master's, was taking a few stats classes, and found myself in an intro to data science class. So that's where I learned kind of the basics of kind of the full stack of how to think about data, how to model it, how to visualize it, et cetera. And then, I fell in love. So I started off learning Python and R concurrently, which I guess I would not advise, but if you can, then it's kind of great to expose yourself to different languages. Then dabbled in a little JavaScript. And I got my first industry job around 2015, where I learned a lot of pandas and sklearn. At the time, a lot of the tools that are available today did not exist. But as time went on, I kind of learned more stuff, so SQL, Keras, Dask, PyTorch, SageMaker, a little bit of DVC here and there. And I wrote Pandera around here, and I wrote UnionML this year over the course of a month or two. And so, obviously iterating on it as you do with open source software. And this is basically my journey so far towards data-centric MLOps, which is something I'm very passionate about. So MLOps is essentially the practice and process of deploying and maintaining machine learning models in production reliably and efficiently. And I think it's sufficiently different from DevOps, mainly because of this idea that, the whole software 2.0 thing. I mean, I don't know if you buy into that, but the idea is, you're creating the meta program that learns from data that then spits out another program that then you use for some purpose like prediction or forecasting or, filling in unknown values that you don't know because it's in the future or just because you weren't able to measure it in the first place. So with MLOps, you have to deal with data, which is very messy to deal with. You have to deal with models. And basically, models are isometric to the data. They learn a set of weights or some decision tree or whatever your algorithm is. And the data constrains what that program, the learned program is at the end. So those two additional elements of versioning and keeping track of data and how changes to those change the model is very different from writing deterministic code that, does the same thing every time you call it. Every time you train a model with a different random state, you potentially get something else. So essentially, my point is MLOps is complex. And in theory, it should be easy. We should have tools to make deploying and maintaining these artifacts, these functions, these learned function approximators easy. But we're kind of at the Cambrian explosion of the tools now. So it's really hard to decide which ones to use, how to put them together. And it often requires different expertise to spin up the infrastructure, write the code, train the models. Like, this is not something one person can do. And the common way that people handle this complexity these days is the directed acyclic graph, DAGs, the data pipeline, in addition to some kind of orchestration layer that handles when things are executed, at what point, how to provision resources for particular applications. But these days I've been thinking a lot about what would higher level abstractions look like above the DAG that would help ML practitioners be more productive and ship things faster and more reliably still. And to highlight 3 problems that that I've come across in this whole process, one of them is code duplication and skew. And what I mean by that is, as a model developer, I'm going to create my data transformation steps, my data preprocessing steps in the lab, and I train my model, I iterate maybe for a week or 2. And then I decide to put it in production, and depending on how mature your team is or how far along you are in the journey, when you ship that to production, the ML engineer or whoever is deploying it might be a different person, and they're going to have to re-implement that maybe not ideal, inefficient, thing that you coded up really quickly in a Jupyter notebook, right? And so this leads to potential skew in the implementation of, just say, the feature engineering step of your pipeline. So that's problem number 1. 2 is this problem of the proliferation of data and ML frameworks. I think this is, overall a good thing. As someone with a biology background, I think, we are but an extension of evolution. So, there shouldn't be one true language or one true framework. So it's a good thing that a lot of different people are trying to do different things and have different syntax and programming paradigms for building these ML models. But it is still a problem because you look at the ecosystem, and I'm sure you've seen those cheat sheets, and there are tons of packages and vendors out there. And then finally, there's this thing I like to call the deployment chasm. It's like you've gotten, your test performance is decent, you're ready to deploy, but then again, you have to deploy it. How do I decide, what is my use case? Do I need a batch prediction? Do I need, API function, API online predictions? Do I need to do it reacting to some kind of stream or some kind of event? So there are a lot of different options here. And basically, going back to the higher level abstractions idea, is it possible to define a standard set of methods or functions for machine learning specifically that can be reused across many different contexts? So from training the model in the first place, maybe tuning it and doing batch streaming or reactive prediction. And we drew inspiration from the standards in web protocols, right? So these are fairly well established these days. It still does evolve, but anyone who's worked with the web are familiar with some of these. Actually, I wasn't familiar with a lot of these, but the really common ones, there are well-defined contracts and expectations about what these things are supposed to do, when to implement them, when not to implement them. So what might this look like for ML? And actually, I would argue we've sort of already informally converged on a set of functions, right? So for models, if we just look at the high-level ML frameworks, right? I'm not talking about TensorFlow and PyTorch because you still have to handle, like, the backward pass kind of, call and all that stuff. But with things that just have a fit method, right? That's how you train your model. And a lot of these have a predict method also. And a lot of these have some way of collecting a performance metric from that model on some partition of your data. So that's all well and good for models, but the world of data is a lot messier, right? The variability there and the use cases and the way you handle data is different. But I would argue that we've sort of converged on certain verbs as well, right? So you always need to read data from some data source. You're always going to need to load it into memory. So if you read data and you persist it in some database or Parquet file or something, you need some way of loading that back into memory. You want to be able to split it into training, test, validation partitions. You want to be able to parse, in the case of supervised learning, features and targets. You want to be able to transform that data into some training or prediction-ready format. And in some cases, like with deep learning, it's an iterative algorithm to continue updating your model. You might want to iterate through batches of your data, since a single pass through millions of data points might not be feasible. And finally, you want to be able to monitor the data in the lab and in production. So this ties in with data validation and model data monitoring. So this is an aspirational tagline, by the way. But so UnionML is something that we developed at Union AI, where we're trying to make it really easy to build and deploy machine learning microservices, and all centered around this idea of an app that's very similar to a web framework's idea of what an app is. And so UnionML is built on top of Flight, and actually there's going to be a talk, going to give a talk tomorrow on Flight, but I think it is worth it to go into a little bit of a sidebar here to just go through briefly what Flight is all about. So Flight is an orchestration platform, think Airflow or Prefect, but it has certain things about it that are data and machine learning aware. So you can pass data between nodes in your graph. You can pass models between nodes in your graph. That'll only be really clear when I show you the code, which I won't for now, but I did want to share some of the core concepts, right? So tasks are the smallest unit of work in Flight. And you can think of a task as just like a Python function that is Docker containerized. So it's completely isolated in its dependencies. Tasks are also language independent. So even though the primary SDK for it is in Python, we also have Java and Scala and JavaScript SDKs. Depending on how on demand, R and Julia, whatever, you could implement SDK for that as well. Tasks are versioned, and they're also strongly typed, so that uses the Python, actually ties in nicely with the previous talk. It takes advantage of the fact that you can type annotate the input and output functions, inputs and outputs of your function signature, and I'll go into why that's actually important a little later. Workflows are the way you compose tasks together to build more complex applications. And, So data flow is a first-class citizen. So when I invoke a task and I feed its output into another workflow, Flight automatically handles the serialization and deserialization of, say, a large Parquet file based on using a blob store. But all of that, you don't have to handle any of that. Flight handles that under the hood. Everything from tasks to workflows to the executions of those entities are versioned. So you can roll back to previous version if a bug is introduced. All data and model artifacts are tracked. So when I execute this thing, and this is a model, I know the data that was fed into that particular execution. And there's another cool little feature here. It's dynamically recursive. So I could nest this workflow, could actually be this workflow, calling this workflow. And so you can do recursion there. It's kind of a little bit of mind-blowing thing, but that is supported as well. Flight supports launch plans, so you can schedule things on a schedule on some regular cadence, and you can give it like default arguments. You can even pass it the timestamp of when the thing was launched. The static typing or the type annotations, right? So if this task outputs a data frame and this training model task takes in a list of dictionaries, Flight's going to say, hey, a data frame is not a list of dictionaries. These things are not compatible. Even before running the code, I know that at least at the boundary, at the interface of these two tasks, that there's a bug already. It's also language agnostic, so I can containerize my task and have R code inside it, and I can execute that. But the rest of the task could be in Python, so you could execute any, as long as you know how to package your Docker container with some kind of executable file, you can do that also with Flight. And finally, is it finally? No, this is not finally. Yes, declarative infrastructure. So this is really cool because essentially you can spin up Spark and Ray and coming soon Dask clusters. You can declare that in your task definition. I think I have a slide on that a little bit later. But these will be ephemeral Spark clusters that you can provision with whatever memory and a number of replicas you need to get your job done. And again, passing data and artifacts between these things are done automatically. It's pretty magical. And I think this is the final point I want to make, but there's the first-class notion of projects and domains, so you can split up your code and your workflows into logical groupings of projects. So you might have a data ETL team, a classification model team, a forecasting model team, and you can use GitOps practices to progress your workflows from development to staging to production very easily. So that's the end of the sidebar. Because this venue is quite a maze, just gave you a little map. So the talk I'm going to give with Haytham tomorrow will be in the Digital Cities AI track at 11:40. So if you want to learn more about Flight and how the code looks like, you can join us there. But the point of going into all of this is that because UnionML is built on top of Flight, as the core author, and there are a few other maintainers, but writing UnionML was fairly easy because I had so many of the primitive building blocks that all the properties that I want in a reliable, robust system are already there in Flight. UnionML simply adds a little, syntactic sugar to realize this goal of making it easy to build and deploy models. And I can, take advantage of all the different integrations that Flight offers, as well as extend it for things that it doesn't currently support, but UnionML could in theory. Another party going on in the background, which I'm going to try to shout over them. So the idea behind this whole microservices thing, right, is I can create this UnionML app, and I can basically, I can deploy a bunch of microservices with just a simple command, right? So I build my app, and I basically can deploy a bunch of these things toward different targets depending on what the use case is and what the requirements are. So, for training, I might want a cluster. For batch prediction, I also might want a cluster since I'm like bulk loading a bunch of data to generate predictions. But for online prediction, I might not need a huge machine. I might need maybe a simple web server to serve the predictions. So this is the main idea. So just to show you the minimal happy path for UnionML, assuming you're working with data frames, mainly that's it. That fits in a few tens of lines. I think that's, yeah, I didn't count, but basically, the first thing you do is you define this data set and this model object. And what the data set is it's a specification. We haven't materialized any data yet, but we're basically making what is, if you're familiar with FastAPI or Flask, this is like you're instantiating your app here, and you're binding the data set to the model. And that makes sense because the model is informed by the data set. If the target of my data set is a binary variable, I can only do classification models. If it's a continuous variable, maybe then I can discretize it into a classifier, but I can also do regression on it, right? So then the next step you do is you define a reader, and basically that is how do I get data from the external world. I define a trainer, how do I train the model on features and target. How do I evaluate that estimator on features and target? And how do I generate a prediction with my model and features? Notice here that this is the complete minimal example, and there's no test or training split, right? I've already said I want a test size of 0.8. I want to shuffle it, and my target is this target, key. So the idea is that I can implement these functional entry points that are not stateless. You just think about the function, you think about what the contract of that function is, and you're done. And what's the micro and the micro framework idea of UnionML is that if I look at sklearn, PyTorch app, and Keras app, these are all UnionML apps, and the whole idea is that the opinions, we want to have opinions about what those core methods are, those core functions, and maybe how you deploy them. But we're trying to have as little opinions as possible about what framework you use to actually do the work, right? So these are all semantically equivalent. They all do the digits classification task. So as I said earlier, the current in today's, if you pip install UnionML today, you get out of the box these training, batch, and online prediction microservices. Coming soon, and actually today actually supports reactive, like S3 event-based predictions, but to support streaming predictions as well, model tuning, and in my personal wish list would be like model.explain or model.inspect or model or dataset.label, things that will be kind of, the labeling one will be kind of a challenge, but you can imagine like a model.explain having the signature of taking the trained model and some features and generating which of the features led to the prediction, right? Or which of the features are most attributable to the prediction. And just to show you what, the whole reusability piece of this is, let's just go through these three microservices, right? So for the training one, it's fairly simple. You get your reader, you split your data into train and test split, you parse it into features and targets, you maybe transform your features, do some pre-processing, you train your model on the training split, generate predictions, and then you evaluate on both the partitions, right? Take note of the purple boxes because these will be reused in batch prediction, right? I already know how to get my data in from the external world. It might be a SQL query, it might be something else. I already know how to parse my features and targets from the data. I already know how to transform my features. I already know how to generate predictions, so I don't have to re-implement any of these things when I deploy it. Same with online prediction. It's a little different, but I need to implement a little extra thing, so I'll show later the FastAPI integration. But when I hit the FastAPI post endpoint with my JSON payload of features, I need a way to get that payload into some form that then my model can understand. So the punchline is UnionML deploys microservices to different targets, right? So web, serverless, or compute cluster targets. And so I'm going to go through each one of these, one example that is currently supported. So UnionML serve, UnionML CLI ships with the package, but UnionML serve is just a thin wrapper around Uvicorn. So what this looks like is, you have your data set and model definition with those, the decorated function implementations. You initialize a fast API app. You call model.serve, and you feed it the app. You say UnionML serve. You get a local, or remote web server, and then you can hit it. Here it's local. You can hit the predict endpoint that automatically is built, when you do this thing, and you give it, your features payload. You can also turn that fast API app into a serverless endpoint using AWS services. So it only supports AWS Lambda today, but GCP functions would be a cool thing to have as well. And here, all you have to do is define this Lambda handler using the Mangum package, which converts the fast API app into an ASGI compliant app, which just basically turns it into a serverless function. You call SAM build and deploy, and boom, you're done. You have a serverless prediction service. You can also create a reactive prediction service. So you say UnionML init, name of my app, and I use this little template here that ships with the package. And I implement a few things here, and these comments are just stand-ins for the actual code that ships with the template, but this reacts to whenever I dump a features file into S3, it's going to kick off the prediction microservice, and you can write that to whatever target location you want. And then finally, for model training, by default, you can play around with stuff locally on your machine or on Google Colab or whatever. But when you're ready to, scale up, the compute cluster that we use with UnionML is Flight. So you kind of have to have a Flight deployment ready. And what this looks like is you basically configure some, Flight remote cluster. You say UnionML deploy. Oh, perfect. You say UnionML deploy. That builds all the tasks and workflows, the Flight workflows that I showed you before, under the hood. And then basically you just call the command line, say UnionML train. I give it some hyperparameters, and then trains the model. I can say UnionML predict. I can point it to a local file of features, and it's going to send those over to the cluster to generate the predictions. There's a programmatic API, so if you want, you want to do this in Python, there's a model.remote deploy. There's a remote train and a remote predict method. You can, as I mentioned earlier, you can declaratively state what your requirements are. So, if you have a compute-intensive, like Spark job to read your data in, you can simply, this is Flight syntax, by the way. You can say task config. You import some the Spark plugin that you can install, the FlightKit Spark plugin. You say what your memory requirements are, number of instances you want, et cetera, and you have a ephemeral Flight cluster ready, and your Spark code goes here. If you need GPUs, you're using PyTorch or TensorFlow or whatever, you can request 2 GPUs or however many that the Flight cluster supports is configured for, 64 gigs of memory, and you're off to the races. Shameless plugin for Union AI product. So Flight is open source. UnionML is open source. You can spin up your own Flight cluster, but if you're an organization that kind of wants to abstract away the infrastructure, the cluster bit, you can join the waitlist for the Union Cloud product, which is basically a hosted Flight. So it's either fully hosted or the hybrid. We have a hybrid system where you bring your own cluster, and Flight then just serves as the control plane. So really, this is the vision of UnionML. You can build an app in the comfort of your own IDE, and then you can deploy the different microservices as you need them. So you might not need a cluster. You can probably just train, on your local machine, but then you can test out an idea and deploy it to production, either as a web endpoint or as a serverless endpoint. And just to tease you a little bit with the roadmap in the future, there's a lot of stuff that we want to do here. This was basically the MVP that we thought would provide some value to folks. But there's a lot of experiment tracking integrations that we can do, data annotation, model tuning, feature engineering, model serving, data quality and monitoring. So there's a lot of work ahead. But to get to the core of why we built this thing, right? I want a world where I'm not crying over the dread of deploying my model, so I can put my sunglasses on. And if you have like an MLOps engineer in your team, you're not bugging them all the time about spinning up new infrastructure for you, so they can also put some sunglasses on. And we all know this meme, right? Testing in production. I don't always test my code, but when I do, it's in production. I want a world where I don't always push to production, but when I do, it's already there. So thank you for your attention. Check it out if you're interested. We're looking for contributions as well. So if you want to, it's also a very greenfield project. There are not many files. It's like 6 files and, 1,000 lines of code. So it's not much. But if you want to get involved, reach out and I'll be around. So thank you.
Thank you, Niels. When Skynet is built, it will probably be on top of this. Do we have any questions for Niels? Microphone coming.
Hey, Neil, thanks for the lovely talk. And I think you're solving an amazing problem. I've been mentioning this past few days that I'm a self-taught programmer. And very recently, I'll just narrate the incident we went through. We were trying to train a model to read certain documents, to redact a part of a certain data in these documents.
Yeah.
And usually this model training is done by the data science guys, and then it came to us, and now they want a web app, which we're trying to deploy on Django. And the hassle that we've been through, and it's still going.
Yeah.
So kudos again to what you're trying to do. I'm not an expert, but I think this will help me get there.
Yeah.
The question is that with this kind of a solution, do you see in time ahead the ability to classify, train, deploy, as you make it easy for developers may be able to use this and turn it into a no-code solution for the world. Do you see that, and is that part of the goal?
Yes and yes. Yeah, the longer answer would be, there's like a pendulum swing between low code, no code, and I don't know what the opposite is, high code. But you can't anticipate every use case, right? So you want to have like a kind of layered API where your no-code solution hits a lot, some 80% of use cases really well, and then when you need to get into the code, UnionML is sort of that intermediary layer. So the plan, we don't want to overplan for this, but if UnionML does succeed, i.e. gets downloaded and gets used a lot, we do see a future in which that is another kind of layer, and then there's another no-code thing on top of that. So yeah.
Thank you.
Any more questions?
Thank you. I need to show a percent of progress in the front end, in the progress bar for the application, your web app, or something else. And with UnionML, how can I show a percent of training your prediction to front end?
Yeah, so basically you're asking, is there a UI that comes with this?
Yeah.
Where I can, no, well, so that would be part of the no-code thing, right? That would be like a stepping stone to that. You know, I'd recommend looking into Streamlit or Dash or any other, you know, web UI solution for that. Currently, UnionML doesn't ship with this, and we don't really have plans to do that. But you can certainly, it is built to work well with these other solutions. So we don't want to do too much. We kind of want to focus on sort of the core methods that can be shared across different use cases and applications. But in terms of interactive UIs, I don't think we'll delve into that anytime soon. But we will likely have like some kind of examples, like repo of examples that use Streamlit, for example, to hook up your UnionML app to a front end. Yeah.
I think we've got time for one more question if there is one. If not, thank you, Niels.
Cool. Thank
Great
you.
talk.